The first thing we gotta do when coming to a limit like this is make sure that it's indeterminate so that we can use the L'Hopital's rule. In order to make sure that this is indeterminate, we're going to sub in what we are approaching. So we're going to go e to the 0 power minus 0 minus 1. And then on the bottom, we're going to say cosine of 0, and we're going to subtract 1. On the top, e to the 0 power is 1. And so we have 1 minus 0 minus 1, which is 0. On the bottom, cosine of 0, if you guys remember back to your unit circle days, right here on that point at 0 degrees or 0 radians, we have 1, 0. So that means cosine of 0 is 1. And we subtract 1, we get 0. So we have an indeterminate form. Now we can use L'Hopital's rule. So when we take the derivative of the top and the bottom, this is what we get. Okay, derivative of the top, derivative of the bottom. Derivative of e to the x is just e to the x. So I just write e to the x again. The derivative of negative x is going to be negative 1. And then the derivative of a constant is 0. So the top is done. Now the bottom, we have the derivative of cosine. Derivative of cosine is negative sine x. And then we have the derivative of a constant, which is 0, so boom, we're done. So now we have the top and the bottom. We just L'Hopital'd this thing. We're going to take the limit as x approaches 0. So let's try it again. Let's try to plug in this 0 again and see what we get. We get e to the 0 power minus 1, and we have negative sine of 1. No, I'm sorry, of 0. I'm plugging in 0. Okay, so the top I get, this is 1 again. I get 0. Oh, man. And on the bottom, what is sine of 0? Well, that'd be over here, and sine is the second number in our coordinate, so we get 0 again. Actually, we get negative 0, but there's no such thing as negative 0, so we have 0 over 0 again. So, we do L'Hopital again. Take the derivative of the top. We have the derivative of e to the x is just e to the x. The derivative of 1 is 0, so I don't have to write it. The derivative of negative sine, let's see what we get. Derivative of negative sine is going to be negative cosine x. And now we're going to take the limit of this as x approaches 0. So we plug it in the top. We get e to the 0 power. We plug it in the bottom. Negative cosine of 0. On the top I get 1. On the bottom I get negative, what is cosine of 0 again? Uno. So we put a 1 right there. And now we have a negative 1. Oh, bam! That's our answer. Now, if you're untrusting like me, I would take this function right here and I would plug it into my calculator and I would approach 1 or 0 to see if it actually is negative 1 because I'm just interested. And that would be actually pretty satisfying. Alright, let's look at this next one. Assumptions matter. You can't make assumptions here. Can L'Hopital's rule be applied to this? So we're trying to see if we get an indeterminate form. So, limits, there's many different ways to do limits. The most simple and basic way is to do substitution. So I'm going to take this one and I'm going to plug it into these x's and see what we get. So let's see what we get. We have 1 raised to the second power plus the 1. We have 2 times 1, add the 1 again. On the top I get a 2, on the bottom I get a 3. Do we have an indeterminate form? No. This is our answer. But the question says, can we use L'Hopital's rule? Hey, well let's try it just for the hey of it. Alright, so the top, I take the derivative of the top. What is the derivative of the top? It is 2x. I take the derivative of the bottom. I get 2. See? Okay, and then I take the limit as x approaches 1. Alright, we got a problem here. This simplifies to just x in there, and if I plug in 1, I get 1, which is not right. So, doesn't work. Don't assume that you use L'Hopital's rule every single time. All right, you have to show that it is indeterminate first.